Hello friends, greetings. Welcome to How to Villain channel. This is DB Villain Stream. Today in this video, we are going to see how to fix a control field corruption created by an IO error in a physical standby database in Oracle. Let's get into the video. Um, yeah, so as usual, we will go through our steps and our complete steps that we are going to follow as part of this video. Objective: we have a data guard setup with a primary and a standby setup. And the control file on both primary and standby are multiplexed. Multiplexed meaning you have more than one copy of the control file. So which means that it already provides you a tolerance against the corruption. But still you cannot survive with the corruption. Just that you don't need to immediately take a downtime and fix it. If you have a single copy of the control file, you'll have no choice. You need to immediately take a database shutdown or maintenance window to fix the control file corruption. But if you have a multiplexed copy, you can avoid the immediate downtime, but still you need to fix the control file corruption after a while. And in this scenario, one of the copy of the control file in the standby database is corrupted. So our objective is to detect the control file corruption and fix it as well. All right. So the first step is to validate the health of the primary and standby database. As usual, as in our setup procedure, which we normally follow. So this is our standby environment. I have a color of yellow. You can see here, this is standby database. This is the environment variable. I am using 12.2.1, but it will be the same case with 19C as well. And this is our primary environment. So you can see, yeah, this is our primary setup. And this is the alert log of the standby. And I'm just running a VM stat on the other screen to every 2 seconds once I'm collecting the IO statistics and other statistics on the machine. So probably I'll cancel this. I'll initiate it with much larger timestamp. All right, let it continue. So now let's get into the action. Let's check the health of the primary and standby. So let's check the primary first. So primary is here. Let's verify if we have both the DBs and listener running. So listener is running. And in my case, the primary and standby database are running on the same server, but it's normally not the case in most of the environment. 99% you will have primary and standby running on the separate virtual machines. Very rarely you will have primary and standby running on the same machine. Maybe in my case, I'm doing it for my practice, so I'm keeping it in the same machine. But in enterprise, it will definitely be in two different machines. So next, so let's connect to the DB. Let's start the health check. So set the formats. This is for the primary. Let's add one more status, database rule. Right, primary. And instance started in 23 hours, right? Parameter config to see if you have a standby. Yeah, we have a primary and standby setup. Just it's not needed to health check, but just I'm doing it. So here you can see this is a standby environment. And this is for the standby. I don't think I have any restore points. Just yeah, I don't have any. What's my current sequence number? 6024. Don't think it will be used. I'll just check data file. Yeah, it looks good. Check my registry. That's also valid. So our control file looks good. And just for example, all right, max of we'll just see what's the header timestamp here 2305. Let's now go to the standby. Oh, come on. Sorry about the pop-up. Um, so let's see if our stand bill looks healthy or not. It's mounted. Yep, mounted. And it's not mandatory, but still I check. It's fine. Log archive test is looking good. And is MRP running? I don't have a data guard broker setup, so I'm using SQL Plus to initiate my MRP process and shut it down. So it's a 64, it's applying the log. You saw, if you remember, we were having 64 here is the current sequence, so it's using current sequence to apply. So it's using the current arclog sequence. I think the recovery is using the log file. So because the amount of volume of archive that we have generated is very minimal. So is 2 point nothing, and standby here VDALA log is meaningless. Standby log is meaningful. Standby log, primary log. That's how we need to check. So you can see here we have 64. I think the recovery is happening in memory. So let's check our data file. So here let's take down the information about control file. We are going to corrupt this control file. So these are the two control files we have. And I have already initiated the recovery, so I don't need to worry about it. Let's see if there is a lag. It's as of 23 hours, and, but it's not showing the exact. So this is going to show only at the time the last sequence we played, but it doesn't show you the synchronization status. It just says that you don't have any lag in terms of the sequence file. But are you having any lag or not? You check it using this command. You can see here, I don't think we have any lag. They are in sync almost. Okay, same server means the timestamp will not show any difference. So zero lag and distinctive checkpoint time we already measured. Okay, there you cannot verify the registry. Now we need to validate the whole health of the DB, but I'm not going to validate the health of the DB because I already ran the health validation and I didn't have any problem. But we can run it. It did not take a lot of time. Just run this. So first of all, we need the control file validation. And if you see, we don't have any corruption on the control files. So blocks failing 0, status is okay. 652 blocks. Here one block size is 16 KB. I will show you how to validate that. And then I'm running a validation command on the database level. It will finish in a minute. Let's give it a minute. It should finish. You can see at this stage, you should be generating some IO. You see, we're generating nearly 150, 200 megabytes per second. I think it's done now. So this is the amount of IO we generated. Yeah, it finished 0, marked corrupt. Blocks failing 0, marked corrupt. Blocks failing 0, marked corrupt. 0. Okay, everything is 0. SP file and control file are reported okay. 652 blocks examined. Now let's do the next steps. So we verified both and they both look good. So I just note down this information. For the last one, I don't think we need to capture the output, but for this one, yes. And I will be posting this outputs to my blog posts, and I will leave you the URL. You can take a look. Next is we need to use dpv command to verify the control file individually. So let's verify it. So how do I know it's 16384 block size? Let's do that. Control file. You see here, block size is 16384. Number of blocks we have for this control file is 652. So this tells us that the block size of the control file is 16384. Now what did we say? We need to run the dbv command. Let's run the dbv command. This is one copy. This is for one copy of the control file. And failing is 0. Failing is 0. Failing is 0. Marked corrupt is 0. Encrypted is all okay. Now we need to run the same DBB on the other file as well. And be aware, we are not going to touch this file, but we are going to corrupt the other file. Process failing data, failing index, failing segment, marked corrupt 0. Why I do all this validation? Because I just want to be sure that before I do the corruption, I don't have any corruptions left already to address. And if I have any corruption, then it will become a problem after I create a corruption. I do not know whether the corruption came from the action I did or it was already there. So that's the reason I already verify that we don't have any outstanding corruption, and we can proceed with the next step. So store the output. I think I copy pasted it in the wrong place. Yeah, here you go. Just give me a minute. Next is take a dump of the control file. There's backup control file to traces. So we took the date control file trace. Okay, now we are going to take down the control file. The block we are going to corrupt. I'm going to take it out. So if you see here, I am running a dd command with the input file pointing to the control file 01, output file pointing to this file, and skip 99, meaning I will be skipping the first 100 blocks. I mean 99 blocks, and will pick up the 100th block, which is 16 KB in size, for one block only. So the file size should be 16 bytes. It's already 16 bytes, you can see, and it will be having a jumbo data only, junk data only. You will not see what is inside this. You can see it's empty. Okay, you cannot see anything. Maybe it's empty as well. Who knows? Anyway, next, launch the DBB. We already did. Already finished. We need to note on this output. So, all right. Next, I already finished DBB. Corrupt the control file. So before I corrupt the control file, I take ls-n output. Show you that one file that we are going to corrupt. Let's take sha1 sum. This file. This is a file we are going to corrupt. Now let's corrupt the control file. You can see here I'm using input file as dev0, which generates continuously a stream of 0 bytes. Output block is output file is this control file 01 control file, and I'm going to seek 99. So there is a difference between seek and skip. Skip is for input file, seek is for output file. It does the same. So it skips the first 99 blocks, and then it starts writing. What it writes the dev0 to the 100 block. And what's the size of the block? 16 KB. And how many blocks it writes? Only one. That's what this command means. Let's write this. Okay, it's done. Let's see. You see, as soon as we wrote, it continuously throws it. Oh my god, we got our instance terminated. I don't believe this, guys. Why would it terminate the instance? I have another copy of the control file. Oh my god. I thought it will survive this corruption. Oh, come on. Alright, I thought it's a multiplex copy is going to save us. It's not looking good, correct? I corrupted only one copy of the file, the other copy is still there. Why should it crash my instance? All right, fine. Let's continue whatever we wanted to do. You can see the 01 copy is shrunk to 65K versus the other file is still 108 10 MB. If you notice here, before both files were of 10 MB in size, but now it became 65K. Maybe it's very huge change, maybe because of that it got corrupted. I have no clue. But the instance is crashed now. See, yeah, that instance is crashed. So we have no way we can bring the DB app back. And anyway, we have a way to fix it, right? Let's try fixing it and then let's start the DB. Yeah, it's done. I'll take down one sample of the alert log message and yes. So did it say the block number and block hash? It didn't say that. So the instance itself is terminated. That's weird. Fine, anyway. Let's continue. Take a dump of the corrupted block. Yeah. Let's see how the corrupted block looks good. Looks. So the input file is 04 and I'm taking out the post output. So I'm skipping the same skip I'm doing here. You can see here. I'm not doing seek. Skip. It's the same, but I don't think you can actually not see that, right? It's not 0 bytes. See, so it's 1 byte. When I say it's not fully populated with 0, so we can only see the SHA sum to see if they match. SHA. And yeah, they are same. That's interesting, isn't it? Both pre and post are having the same SHA1 sum. This and this. Yeah. See if it's the same or not. We'll just verify it. All right, let's see if this number's the same. Yep, they're same. It's very interesting why it's same. I thought they may be different, but it's same. Let's run the dbb command because now the instance is not there. The dbb will still work. See file IO error and file size during read operation. The whole file is itself is corrupt, I guess. So it was a file IO error. It says not in one file, but we lost the whole file. It seems. Maybe that's the reason why the instance crashed. So run validate backup validate current control file. All right, let's see if I can start the DB in no mount and run the validation command to see if the backup validate command reports some issue. I never thought it's gonna crash the DB. Let's see. Let's see if it runs fine. Target must be mounted. Okay. I don't think it is going to allow us to mount the DB. It doesn't. Error in identifying the controller. Check the alert log. But why would it fail? Yeah, corrupted control file is okay. But I think the whole file is lost now. That's the reason why it doesn't allow. But anyway, okay, I wanted to test the fix. We know that the corruption is there now. The DBV reported that there's a file IO error, right? And then we have no way to run the backup validate check logicals. So we will just report this saying instance could not be mounted. So Let's take down everything. So we cannot run the validation command in no mount at the same time. Instance is also not allowed to mount. So we have no choice. We have to do the restore now. So instance is still in the no mount stage. You can see here. Select instance name, comma status instance. Yeah, it started. So verify the orchestral. So we don't need to do this sync check for now because the database is down anyway. We need to shut the DB down and then do a copy back, a copy output. This is what we wanted to do. So let's do that. I'll do a sync anyway. I'll do a switch in the primary. So let's take down system. There's a difference between auto system switch log file, auto system archive log current. So I maybe at some point in time I will do some sort of Oracle fundamental training, fundamental discussion. That time I will explain the difference. You can see here I switched it, so it moved from 64 to 65. So now I need to see that standby gets 65 also, but it's already down because of crash created by control file corruption. Preserve the control file copy. Yeah, well, we will preserve it now. Just shut this down before we do it. Yeah. Just takes a minute. Done. All right, now let's do this. I want to preserve both the files for further examination. So you can see I can preserve both the files. Now I'm not going to do any sort of control file location change. I'm just going to keep up whatever it is because I already preserved the control file copy. So if anything goes wrong, I will have this copy to replace the original files. And I'm not going to manually copy the control file using OS commands. I'm going to use restore control file from the good copy. So, right, let's quickly check instance name and status. Yeah, instance is started. Let's do the restore using Arman. Let's see if it reads a good copy. Yeah, and it returned back to the original. Yes, again. So we used the same copy to write both copies. Okay, fine. Let's see if there is such a one sums match. The one we have. So this is a good copy we had. The new ones that were created, do they such a ones match? No, they don't match, it seems. Maybe it stores the information about the backup, so could be that's the reason. There's a backup now. Yeah, it's 10, 6, 9, 8, 7, 5, 2. At least in the size wise, it's matching. Let's now do a DBV to see if the file is still corrupt. Yeah. Now we have failing 0, failing index 0, failing segment 0. Yeah, all looks fine. Now I'll do this. So control fill from. Okay, the DB is mounted. Let's run the database check, the validation check. And then we can take a dump of the control field trace to validate if the control field looks good. So now this time again, control field looks good. Yeah, we have one more DBV, but so we need to mount the DB before we run the validation command, isn't it? So, oh, okay, because it's mounted, then only we run the validation. Okay, I think I'm not paying attention to my own commands. Okay, fine. Failing data 0, failing index 0, failing segment 0, marked corrupt 0. So this looks fine. And next, so as far as the fixup routine is concerned, yes, we have completed the fixup routine. We have no issues. So the only concern that I have is that we are not able to create the corruption successfully. That's it. But apart from that, I think it was. I think it looked good to me. All the steps were running fine. So right. So we have secured the logs we need, and I think I'm good, guys. Oh, we forgot one piece. We need to put the DB back in synchronous mode and see if the archaeologs are getting shipped. So let's check that. And then we can close this video. Yeah, let's do the health check. We need to check the alert log at the end. I'll check that. Yes, a physical standby. Mounted. Let's keep the log archive as well. Yes. There are no parameters going to change, but MRP is down. Let's initiate the MRP. Let's see in the alert log if the MRP gets initiated successfully. Yeah. Starting the MRP, yeah, and it's 64 and 65 it already picked up, completed. MRP is supplying 65. I think we moved to 65, I guess. Yeah, 65 is current, so 66 is current, so that's properly picking it up. See here, we have standby log 66 also. And what's the max? Yeah, it's 0040. It is 0040 as well. So that looks fine as well. Now I need to just check the log wise sync up. Is there any lag in the number of archives that were applied? No, there is no gap in terms of the sequence number, and it's applying from memory. So database archive logs are recovered from memory. So logs are getting recovered from memory. but I'll try to take one more control file trace to be sure we don't have any other issues. Let's see, the control file traces are still same. One before and one after 9587, 9587. Yeah, they're same. So the DB is in sync, MRP is getting applied. So let's just preserve this output as well. Step 14. Bring back DB application. Check constant because that's the one we had the database crash. Looks fine to me. Now we need to do one thing. We need to check the alert log. This during RDBMS mount. Okay. Then control corrupt only we have. Okay, fine. This is control for corruption. Okay, this looks fine. Right. Other than that, control for corruption message, we don't have any other corruption message. We also fix the corruption. That's important. Now let's go ahead and go through our plan again. What did we do and summarize it. So the control file corruption was in the physical standby. Control file is multiplexed. So when we tried creating the corruption, so before we actually try to identify or detect the corruption, we actually validated the health of the primary and standby databases. We ensured that the standby database is in sync with the primary. Then we also verified the standby has no corruptions anywhere. So we checked both physical and logical structures. We ensured that the database or the control file doesn't have any corruption at that stage. And we used dbb command additionally to verify there are no corruptions. Then we decided to take the a dump of control file trace and a dump of the block we are going to corrupt out. So we took that and we wrote one unit of or one block size of 16 KB back to the control file. But that resulted in overall IO failure in the control file and the instance crashed immediately. So as per our plan, we know how to fix it. We just do restore control file from the good control file copy, then automatically the restore finished and there are no corruptions now. Database is also in sync. This is what we did as a part of the exercise. But ideally I was expecting the multiplexing should have saved my DB, but this sort of IO error, I think it's like losing a copy of the control file completely. I think in that situation it's not going to survive. That's what we learned today. Thanks everyone. I think you might have, I hope you like this video. If you really like this, give me a thumbs up and please feel free to share your valuable feedbacks and share this video with your other friends. So if you have not subscribed until now, please see if you can subscribe to the channel. That will give me some motivation to do more videos like this. Thanks guys again. I think this is after a long time I'm doing an Oracle video. Thank you.